I would like to invite Madam Aishah and Mr. Roslan with the DAS to present the research on DAS Advanced Math Curriculum. So while they are setting up, I'll just give a short introduction. Madam Aishah has a combined 46 years of mathematics teaching experience in MOE primary schools as well as DAS, Bishan and Yishun branches. She is a pioneer member of the DAS Mathematics core team and is currently designing an advanced math curriculum. She has presented at the Special Education Network in Asia conferences in 2014 and 2016. Mr. Roslan holds a master's degree in education from Murdoch University and has 16 years of teaching in DAS alone. He has experience teaching in MOE secondary schools as well as mainstream schools in Brunei. He has conducted numerous workshops for teachers and the public in Hong Kong, Malaysia and Brunei. All right, let them take it away. Thank you.
Good morning, everyone. Can everybody hear me? From behind there, everybody can hear me? Yes? Okay, right. This morning, myself, I'm Aishah, and my colleague Roslan, both of us are lead educational therapists with the Dyslexia Association of Singapore, and we are going to present on a topic that is close to the hearts of Singapore maths teachers, and that is the challenges of problem sums. During intervention time with our primary 5 and primary 6 students who are taking standard maths in school, our educational therapists found that maths word problems, which usually consisted of more than 60% of the exam paper, were most challenging for our dyslexic learners. The students encountered difficulties in qualitative understanding of the problem statements, the information that they were given, the constraints, and what they were required to find in the word problem. They lacked the skills for solving word problems. They lacked the perseverance in successfully carrying out parts or all of the complex processes that were involved in solving the problem. The students also demonstrated difficulties in organizing and presenting their working steps systematically. Not only had they to deal with more than one concept being tested in the same word problem, they also had to carry out multi-step operations. Here is how quite a number of students would work out their word problems. Leave the question blank. Jump into a solution attempt and hope to get it correct. Disorganized working steps. These look familiar to you, right? Yes. When faced with word problems, students did not attempt to sufficiently explore the contextual clues and entry points to the solution. They expected teacher to scaffold the solution processes for them. These difficulties affected students' performance in completing their daily workbooks, worksheets, homework, and even school exams. Thus, a problem-solving framework was very much needed to address these issues. Students needed a problem-solving framework for solving their word problems. They needed problem-solving skills. They needed a structure for presenting their working steps. And they needed a strong knowledge of the heuristics that were required for them to successfully work out the solution. Thus, the DAS Maths team designed and developed the problem sums for upper primary curriculum, which Just now you saw the name Advanced Maths program. It is now changed to the Problem Sums for Upper Primary Curriculum, implementing our very unique Try, Share, Learn, Apply approach. Students in the Essential Maths program who show a firm understanding of the maths concepts could progress onto the Problem Sums curriculum. The primary focus of our unique approach is to empower our students to solve routine and non-routine word problems via collaboration and interaction with peers, thus strengthening not only their thinking and math skills, but also developing confidence in sharing their strategies. In the try stage, students try first to solve a problem. In the share stage, the students explain how they reach their strategy to their peers. At the learn stage, the teacher draws out the important points in the word problem and recommends a suitable strategy for solution. After that, students apply what they have learned with a few other word problems. At the end of the lesson, students bring home one word problem as a reinforcement homework task. At the next lesson, the teacher will mark the sum, go through the key concepts in the problem, and after that, the students do one test question, which is to inform the teacher of the competency level of the student. When the teacher has assured that the child is competent enough in that particular concept, a new concept would be introduced. And now my colleague Roslan will take you through one word problem in the Try, Share, Learn, Apply approach.
Thank you, Albel. Here comes the maths teacher. Okay. Now, my role today is actually to be the maths teacher, but I'd like to assure you actually is the friendly maths teacher, the one that does not intimidate the children. Now, this morning, actually, if you listen to Dr. Vivian, the keynote speaker just now, she said that actually students with learning issues usually tend to have a high level of anxiety, panic, distress. That's very true because that will affect exactly their performance. When I talk to my students in maths, if you listen carefully what they say, it's not about maths that they don't like. I'm sorry to say, but they will say, oh, my teacher, my very fierce Miss so-and-so like that, Mrs. Lee like that. If you listen carefully, so I think it's because the unpleasant experience that they have had in dealing with maths. So ours as well as consistent with the OG principles, that is basically, we must not intimidate the children. We must give them a sense of empowerment. So today I'm going to illustrate to you exactly the approaches actually we do for our lesson. You'll be doing the clicking. Thank you. So we will walk you through, actually as the word suggests, actually I'll walk you through, so I will not be calling any one of you exactly and put you on spotlight to ask questions. So relax, yeah? Okay. Okay, let's say this is typical, taken from an actual paper. Unfortunately, I'm a big size, exactly. I always have this in my class. My students say, Chair, cannot see. Everybody okay? It's okay? Look at this. Sally made some donuts. And then she gave 1/5 of the donut to her relatives. It doesn't end there. And 30 of the donuts to her friends. So that actually left her with 2/3 of the donuts. Then she packed this into 18 boxes. And not enough with that, 2 sizes. My God, actually. This is very typical of maths problem. So I want you to analyze this first. For example, 1/5 of them refers to donuts. And then 30 of them, the donuts again, to her friends, which is on top of the 1/5. And then she left, suddenly the denominator has changed. So she left with 2/3 of the donuts. And then she packed this into 18 boxes. That will be easy. But then again, of 2 different sizes. A small box contains 6 donuts. while the big box contains twice as many. And twice as many of you, some students they don't get it quite clearly. So how many donuts? This is an essential question. How many donuts were packed then into the 18 boxes? And how many boxes contain 6 donuts? I just want you to be honest with me, even for adults, it takes quite some time because, my God, actually. But adults, you have choice. You have choice. You can just push it away. But children, they don't have choice. They have to own this, actually, because given to them, they have to solve it. So usually what we do in class, actually, we give them actually a lot of time actually to discuss and understand the story. Their bad habit is actually they like to jump. Whatever phrases that seems to be familiar to them, they will just jump, and then they will start with the wrong operation. Okay, so let's do it slowly. So the next clicker, the next slide. So we say, okay, 1/5 of the donut was given, so that leaves us actually with 4/5. And then she gave 30 donuts, actually, eventually, she's left with 2/3 of the donuts. So 2/3, actually, we like to give them the visual representation of what 2/3 or how 2/3 looks like. So as we find a common factor, over there, use the denominator digit to divide each of the 5, because we want to change fraction of 5 into a fraction of 3. So that's the working there, 2/3 of 15, so we have 15 subunits. Yeah, from the 1/5 just now, we have 15 subunits there. So this is actually 1/5, the one not shaded. We will have to deal with actually the one shaded. So you can see that we have 15 subunits, and then 30 donuts actually are given, and left with 2/3. So you have 2/3 there. You can see, look over here, this 2/3, excluding the 2 subunits, which equivalent to 30 donuts. So therefore, next one, Aishah. So therefore, actually, we say actually 2 parts, okay, subunit equal 30 donuts. That means 1 subunit equal to 15 donuts. Okay? So 10 parts equal, therefore, 10 to 15, 150 donuts, the one that shaded just now, or 150 donuts equivalent to 2/3. What we do in class is actually we have this plastic tile, actually manipulative, where they can exactly see themselves that we can be broken into a fraction of 3, broken into a fraction of 15. So answer A, we have got it, 150 donuts were packed into 18 boxes. Usually we do not go this fast because, like I said, what they like or appreciate much is actually something that they can actually touch and feel and play with. So actually we use a lot of tiles and it's a fraction tiles as well. So now we have to deal with the second part. Okay, so 150 donuts actually equivalent to the 2/3. We want to pack it into 18 boxes. Now this method actually is not easy because they have to make some assumption. Yeah, so they have to assume first that all boxes are small. So 18 boxes times 6 donuts equal 108. Why 6 donuts? Because it's given. If you look at the question just now. So, but if 18 boxes times 6 donuts, or rather put it in simple language, see, every box contains 6 donuts. So that will total up to 108 donuts. But we have 150 just now. So we subtract 100 donuts subtract from 150. So we have 42 donuts still unpacked. Now I just want to share with you exactly, sometimes when we talk to our students here, other than the language, the tone of voice, actually we got to make sure that they follow us exactly, or they follow the story. So we just make them see this is 42 on the table. We say 42 still not packed yet. Now, so this is how it looks like. Look, like 18 boxes, we have 6 donuts. Now, what are we going to do with the 42 so-called extra? Now, again, exactly the big boxes, actually, the big box contains actually 12 donuts. So we put each box 6 at a time. So, Albel. Next slide. Yeah. So we want them to know these are the 42 just now. We divide by 6, we put them 6, and then finally, until we don't have any more donuts. So we say to them directly, now those directly with 12 are the big size boxes. So the final number of big box, 42 divided by 6. So we have 7 boxes, then we add up to the 118. So 18 minus 7, altogether we have 11 actually containing 6 donuts. Those are actually the small size. And then we have 7 exactly boxes containing 12. Those are the big size. And then we said 11 boxes contain 6 donuts. So we asked them exactly that, is this what the question wants to know? So basically we have 11 boxes, they contain 6 donuts. And then 7 big box containing 12 donuts. A bit faster, in the interest of time, I do not use manipulative. Now, another bad habit of them is exactly what they will do. They will just ask the teacher, simply, sir, this is correct, no, sir, this is correct. There are ways actually for them to check, and we want them to be confident actually in their own work. So we can ask them to check, for example, like this. So I said, okay, let's see, I said, Albel, you have 11 boxes times 6, it is 6 donuts. Then Albel, you say you have 7 big boxes, each contain 12, 7 times 12, 84 donuts. So if you add them together, you must get 150. So the child adds and they say, oh yeah, okay, I get 150 donuts. So we can tell them, we can assure the child that you yourself check your work, you're working, and then it is correct because the numbers do tally. Okay? So again, like I said, we do not go exactly this fast in class because the class of science of 3 or 4 students or sometimes 2 students. We need to give them a lot of thinking time, teachers. So later, actually, when I wrap up this session, I will just stress on that. So now I'm going to give Albel to share some of her success story. Thank you, Albel.
This word problem is actually a typical problem that comes out in primary 6 papers, normally in PSLE type. I will now go on to the next part of the presentation, and that is about a pilot study that we conducted with some primary 5 and primary 6 students taking standard maths in school on a 6-month intervention period respectively in 2015. As you can see from the chart here, we had a pre-test and a post-test for them, and they made remarkable improvements in the post-test scores. This is for the primary 6 students, and this is for the primary 5 students. So this pilot study was to test the effectiveness of the problem sums curriculum and the try, share, learn, apply approach. Students not only made significant improvements, but maintained the improvements by achieving better grades in their final exams and also in PSLE 2016. 2 of the students, Suwei and Mei Li, went on to score a band B in their PSLE exam, while a 3rd student obtained a band C. So as can be seen from this chart, they made much improvement in their paper 2. As you can see from the score, the paper 2, Suwei scored 2 marks, but later on, he scored 21.5. Mei Li, in their paper 2, 7 marks, 23.5, and finally, both of them did well in their prelim and also scored a band B in the PSLE exam. Thus, our problem sums curriculum had benefited them. Today, all 3 students are confident with the secondary 1 curriculum. Keep up the good work, Suwei, Mei Li, and Ken Lim. In summary, the key features of the problem sums curriculum. Our lessons are an integration of the OG principles, the CRA, as well as the Polya processes. Our small class size creates a safe place for the students to confidently express and interact their strategies, as well as learn from their peers' strategies. The try, share, learn, apply approach encourages students to effectively organize and articulate their thought processes using precise mathematical terms that explain the concept. Students are taught a variety of heuristic skills to work out the various genre of concepts learned at the upper primary level. They are also taught to make relevant annotations in the word problem to understand it well so that they can work it out successfully. There is also a structure for them to present their workings. And here is an example of a student worksheet that we use in our class for the students to work out the problems. Finally, and most importantly, the design of the try, share, learn, apply approach encourages synchronicity between the teacher, the student, and the rest of the class, ensuring that friendships and bondings are built through teamwork and effective problem-solving skills are developed. With this, I will pass on to Roslan to conclude today's session. Thank you.
I think one principles actually that you can see being consistent across the board actually in all our programs actually with CT and Edmund and also the Yunri and Kailin is actually the OG principles. I strongly believe actually that actually we should not exactly intimidate the child. We need to give the child actually a strong actually encouragement and confidence. Basically what we do, our program is actually we inculcating a good learning habit. Because actually when they learn, they tend to rush, they tend to actually make false assumptions. So basically we just give them actually a very safe environment where we encourage them to think and actually analyze actually their own question, their own work, and then at the same time we give them the confidence of asking questions. Okay, and then last one, this is it. So we want them to articulate exactly what their thoughts is, because actually a lot of actually teaching done in class, basically teachers, 90% of the time, teachers talk. So we need exactly students to talk. This is not easy because they don't exactly open up. So, but once they got that exactly habit, they will exactly discuss and then to work out their solution. So this is our maths program. We would like to say exactly, it's not just about exactly saying it, but it's about the serious implementation of the approaches. With that, I'd like to say thank you very much to all of you.
Thank you so much, Aishah and Roslan. I would like to invite Ms. Chai Su Chow, our Chief Financial Officer, to give tokens of appreciation to both Mr. Roslan and Madam Aishah. Thank you. Thank you.